Hello folks, today we will discuss about virtualization. Sorry. Today we will discuss about virtualization. Virtualization is recent technology which is capturing our enterprise market because it is lowering our capital expenditure, our operational expenditure, which we call capex, opex in our technological term. It is increasing return of investment and total cost of operation as well. Now, if we talk about virtualization, in computing world, virtualization means creating a abstract resource pool from where you can provision multiple software components, multiple virtual machine, or in other words, you can say decoupling your hardware, hiding your physical hardware resources. The common theme behind the virtualization technology is the encapsulation. Encapsulation means having a data hiding mechanism so that a person sitting next to you will not be able to recognize which type of mechanism you are using or what is going through in backend. Right now, suppose you have a Dell server or Fujitsu server in backend and you have provisioned 10 virtual machines on top of that. Then in that case, your virtual machines will not be able to recognize that which server is deployed in backend. That's all about the power of virtualization. Basically, we have two types of virtualization. First one is platform virtualization and second one is resource virtualization. Platform virtualization means suppose you have a hardware platform of x86 server and you are going to virtualize that platform. Means you are going to create multiple software computers which are accessing a particular hardware. In that case, that hardware platform is virtualized. Now, creating a virtual machine by using a combination of hardware and software is called platform virtualization, and in platform virtualization we will have two types of terminology: a backend host, which we generally call server, and that host will provision multiple guests, means virtual machine. If we consider normal host and guest topology, then we suppose I invite you for a party at my place. In that case, I will be your host, and whatever guest I have invited will be my guest. Now, the role of host is to serve snacks as well as dinner and whatever is required or whatever is you plan for your guest. The main role of host is to serve, whereas the main role of guest is to consume. Similar topology is implemented in our technical world. In our technical world, we have host guest topology, and in order to implement host guest topology, we use two different kinds of strategies like emulation and simulation. There is some difference, or you can say there is no difference, but in between emulation and simulation. But in broad way, if you talk about emulation and simulation, then emulation means suppose you have developed some program for your Android operating system on your Windows laptop or Linux laptop. In that case, that at the end of the day, your application is going to execute on an Android phone, but you are designing that application by sitting on Windows phone. In that case, there would be an emulation which will emulate the environment of Android phone by sitting on Windows laptop. So similarly, the process of creating an application for a platform which will be executable on different platform is called emulation, whereas simulation is nothing but creating a technical environment which is similar to your physical environment, like our VMware, ESXi or host or whatever. Hardware emulation uses VM simulate and require hardware. Like we have a suppose we have two hardwares here, hardware VMA and VMB, which are further simulated into multiple virtual machines. Platform virtualization has basically two types: native virtualization and full virtualization. If we talk about native virtualization, it means you have a guest OS. On top of that guest OS, you have installed an uh, hypervisor type of flavor like sorry, VMware Workstation or Oracle VirtualBox. This is called native virtualization. If you talk about full virtualization, it is about having a bare metal server like VMware ESXi, Microsoft Hyper-V or Citrix Gen server. Full virtualizes uses a hypervisor. As I already told that if you want to leverage the functionality of full virtualization, then you should deploy a hypervisor like Hyper-V or ESXi as or Zen server. What is a hypervisor? Very good question. Hypervisor is nothing but a defined operating system. As we install operating system in our environment, similarly we install a hypervisor in our on our servers. You just boot your hypervisors on your server either using physical media or storage area network or whatever feasible technology you have. Once you deploy your hardware, after that, whatever virtual machine you are going to provision on top of your hardware, they are getting their resources, they're getting their hardware resources via hypervisor. And hypervisor will have their inbuilt kernels. They will schedule your IOPS, your CPU resources, memory resources, and IO resources. Right now we have two types of hypervisor. A type 1 hypervisor, which is virtual machine monitor. There are the softwares which run on a given hardware platform, and we have a second type 2 hypervisor, where there are the software which runs on guest operating systems. If we talk about type 1 hypervisors, we have examples like VMware ESXi, Citrix Zen server, and Microsoft Hyper-V. Whereas if you talk about type 2 hypervisor, we have VMware Workstation as well as Oracle VirtualBox. Your type 2 hypervisors will get installed on top of a guest OS, and it will make guest OS behave like an hypervisor to create multiple virtual machines. Whereas type 1 hypervisors are also called bare metal hypervisors, and they are installed directly on your servers like Dell server, HP server, or Fujitsu server. Platform virtualization. Partially virtualizing your environment by using either, we have many examples of platform virtualization right now as CTSS, external IBM M44 or 44X, and arguably such systems like OS and VS1, OS VS2 and MVS are in market, and many more recent systems such as Microsoft Windows and Linux as well as remaining categories of technologies are proposing different projects which are fully dedicated to virtualization, platform virtualization environment. If we talk about virtualization, then we are virtualizing the API calls or the hyper calls coming from a guest operating system application to your hardware. In case of virtualizing that hardware with prior involvement of your guest operating system, we call it the para virtualization, parallel workstation, or anomalism. It is depending upon your requirement and scenario. So at the end of the day, if your guest OS is involved in in bypassing your hypercalls or virtualizing your hypercalls, it is called para virtualization. Para virtualization shared your process with the guest operating system. No doubt, if guest OS is involved in virtualizing your IOPS, then para virtualization will involve that guest OS for sharing your hypercalls. Apps, modified guest operating system, hypervisor, and like VMM and hardware. Operating system level virtualization. Virtualizing a physical server at operating system level is called operating system level virtualization. Like we have several operating systems like Solaris containers, FreeBSD jails, and Linux servers. They are operating system level virtualization. You don't need any hypervisor, and without using any hypervisor, you can virtualize your environment. So simple as that. Operating system level virtualization isolates the servers. Yeah, if you deployed an operating system on top of your server, after that, your servers will get isolated from your virtual machines, and your virtual machine will not be able to recognize your server, how they are working in backend, and what is the mechanism or scenario they are using. Platform virtualization, application virtualization. Running on a desktop or a server application locally, localized resources within an operating system or within a multiple multi-tenant environment. You will have multiple Sun Java virtual machines, software consent, or Altruist regions. These are the examples of application virtualization technology. If you talk about resource virtualization, at the end of the day, if you are creating a virtual machine which is going to behave just like a physical machine, in that case your virtual machine should have those hardwares which your physical machine have, like your RAM, your CPU, your IOPS. Now, in order to create a software version of your RAM and software version of your CPU, you have to virtualize your resources, and this strategy of creating software component, software CPU behaving like a physical CPU, or creating a software RAM behaving like a physical RAM, is called resource virtualization. If we talk about resource virtualization in detail, we have a well-known example like RAID and Volume Manager, which combine many disks into a large logical disk. We have redundant array of independent disk. RAID is 0 for parity, RAID 1 for mirroring. But when you are creating it, this is virtualizing the backend infrastructure, and your IOPS are going to behave like that. Your storage virtualization, which refers to abstracting your logical storage and commonly used in SAN. Particularly when you create a storage area network, there would be a storage box. In your storage box, there will be multiple disks, and on top of your disks, you are going to create multiple LUNs. Now, your LUNs are going to provision your data store, and data store. On top of your data store, you are going to reside your virtual machine files. The physical storage resources are aggregated into several pools, and so in order to communicate between multiple storage technologies, either you can create a VPN, or there would be a NAT, network address translation, accordingly depending upon your FQD and fully qualified domain name. Okay, now resource virtualization. We have computer clusters, we have partitioning, we have encapsulation, and these are well-known functionalities of computer OS limited virtualization, Linux related virtualization projects. Now we have lots of projects. Some are proprietary projects, like from full virtualization project from VMware or JVM project. Apart from that, there are lots of open source projects like Zen, UML, Linux vServer, OpenVZ, BOST. These are under GPL license or LGPL license, and their source codes are available free on internet. You can use that source code and deploy it. Develop a more powerful kernel by using the technology. Apart from that, right now we have OpenStack, which is inherited from a project from NASA, and right now it is behaving quite well for deploying an anti-virtualization environment where you are deploying multiple servers in order to execute a single application. We will discuss about BOSS cap emulation, QEMU, VMware, JVM, and Suzanne server, and Fujitsu server, Linux server, OZVM, OZVM, and hardware support virtualization, Linux KVM. These are the examples of your virtualization. Now talking about x86 virtualization. Whenever you talk about server virtualization means virtualizing your entire server box so that it will be in form of a software. Now, once you are creating a software version of your hardware, you are going to create each and every software component for whatever hardware component in your environment. Para virtualization Now, what is x86 server? x86 servers are those servers which are inherited from Microsoft 808 microprocessor 8086 architecture, and it achieves high performance with less complexity and virtualization layer, but require guest operating system material. Virtual infrastructures. Once you have virtualized your servers, after that, on top of your virtualized servers, you will create multiple virtual machines, and your environment will be called a virtual environment. Physical resources or virtual infrastructure resources. Security tips. lot of security breaches which you will are going to face in your environment, and it will be a havoc for you. So that's all about virtualization and virtual data center. Stay tuned. I will come up with technical details and lab details about how we can implement virtualization in our environment. Thank you so much.